Morning, everyone. Thank you for joining me today. My name is Subhaya, as IT department from third year, and my mini project is about automated food quality analysis using image processing and machine learning. This project was developed under the guidance of Ms. A. Deepa, Assistant Professor of a Department of AML. Today, uh, I have walked through the problem we are solving, our innovation solution, and the result were achieved. Let's begin. I have an agenda to add introduction, statement of the problem, scope of the project, methodology, and architectural diagram, system flow, and algorithm used in this project. Designs are described by the use case and sequence diagram and class diagram. Implementation is done, and the important code segments are done to added to the PPT, and output and result will be shown in the different tab. Now we can go to introduction part. Food quality inspection plays a major role in agriculture, retails, and food industries. In every day, millions of fruits and vegetables are inspected manually in farms, supermarkets, and food processing facilities. This manual inspection has a serious drawback: time-consuming, inconsistent, error-prone, costly, because it ruins train personnel and significant time investment. And different inspectors make different judgments, so inconsistency will be done in this project. And the system is used by YOLO V8 of object detection, image processing technique for feature extraction, and random forest classifier to determine freshness and spoiled finding. That's where our solution comes in. Where we have developed an intelligent system that automatically classify food items as fresh or spoiled in real-time systems. And the project scopes are I have already shown statement the problem problem statements. Human perspective varies, leads to inaccurate quality assessment. Environmental factors like lighting and texture variation affect judgments. Increased food waste due to improper sorting. And in the project scope, let me explain how our system works. Our methodology follows four main steps: data collection, data pre-processing, feature extraction, and classification. In data collection, we gather image of fresh and spoiled fruits and vegetables. We ensure diversity in angles, lighting, and backgrounds. This helps the model generation and between the real-world scenario. Data pre-processing. We resize images to standard dimension 2000, 224 into 224 pixels. It is easy to process and analyze the data easily and fast. We apply noise reduction filters to improve image quality, and we convert color spaces into extract meaningful color information. We normalize pixel values for consistent input. Feature extractions are color features, texture features, and shape features. We capture a structural pattern that indicate freshness and accuracy of the food type, and in the classification, we use random forest and assemble machine learning algorithm. We process the extracted features and predict fresh or spoiled. Random forests are used because it accurate handles noise well and work great with our datasets. And I have inserted the datasets from a Kaggle software, and the project is limited for raw fruits and vegetables based on visible visual features. It may not, it cannot detect internal damage or bacterial contamination. Uh, it also does not handle cooked food, packaged food, or mixed dishes. Accuracy may vary under extreme lighting or poor image qualities. This enhancement can expand the system into a more comprehensive food quality monitoring platform. Here the system flows, user inputs an image via through the Thinkner GUI. They can upload a photo or use webcam for live capture. YOLO 8 detects food items. It identifies fruits, vegetables, and draws bounding boxes. Each item get localized for individual analysis. Features are extracted from each detected items, color, histogram, texture, measures, and measurement of the surface feature. Random forest classifier predict output will be the fresh or spoiled with confidence percentage. It is used to use the users to confidently. We can use the depends on the output of the this project. Results are displayed in real-time process. Users see bounding boxes with prediction and confidence scores. Analyze timestamp is automatically recorded. And methodologies are based. Architectural diagram flow is the system architecture diagram. The user interface should upload the core inspection module. By image processing, the random forest classifier utilize the output and it displays the classification as a fresh as filed, and the core inspection module, the YOLO V8 random forest mode classifies the result in accurate manner. Design use case diagrams are used in my project. Food quality analysis systems are interactive with the users. The user upload or capture an image while the system perform object detection, feature extraction, and classification to show the final result whether the fruit and vegetables are fresh or spoiled. This diagram represents the functional behavior of the system for the user's perspective. And the use case diagrams are this, and next design class diagrams. Um, Although thousands of students attend the universities model one class to another, these are the examples of a class diagram. But in my project, a class is a representation of the project object, and in many ways it simplifies the template from which objects are created. Classes from the main building blocks and building blocks of a object-oriented applications. The sequence diagram is explained for my project. User can use Thinkner GUI for core inspection model, YOLO V8 model, feature extractor. The extractor should contaminate, display the fresh or spoiled things, and the random forest classification will display fresh visual reports. Algorithm used. And the algorithm used in the project is random forest model is used to classify food items are fresh or spoiled based on extraction features. Ensure reliable classification even with complex or noisy images. Example, if a fruit has bright uniform color and smooth texture, the classifier predict it as fresh. If it is show discoloration or irregular texture, it is classified as spoiled. And the YOLO V8 model is a highly accurate real-time object detection algorithm. It performs both object detection and localization, and it optimizes the ordinary GPU computing by faster output and storage in network architecture. Offers improved real-time detection accuracy without increasing interface cost. And the hardware and software selection. Sensors and hardwares are our laptop capturing image of fruits and vegetables with own laptop. If we have a real-time project, IoT enabled microcontrollers used like a Raspberry Pi and Node MCU are optional for remote monitoring. Otherwise, we can use IoT platforms like ThinkSpeak, optional for cloud storage and real-time access. Whether the output will be the color depends on color, temperature, and the st- texture and space features of freshness and spoil detection. Now we can see our code which was developed in our Visual Studio. I have created the visual code and the backend and front end code. Inside the backend code, a database will show stores when the uploaded when we check the uploaded data, it is stored in uploads, and the database program in written by wrote by in Python form, and import create engine integer string float and boolean values are declared if it true or false if incorrect. And the main program also, all programs are to run in the Python. Import OS also used in the set from typing a import list, and the fast API is used to accurately finding the quality with AI, and by creating upload data, the directory will upload save the data to the uploads file, and it create the root message of the fruit quality detection API is running, and the predicting is accurate and real app. This should be background task. Get verified data from the users, and if users confirmed correct, use the predicted label to incorrect or false, incorrect or correct with a complex true label implemented.